Magnetic motor starter overload operation. Let's see how these overloads work on a magnetic motor starter versus just the basic manual motor starter that we looked at earlier. So here's our solder pot overload, or our melting alloy overload. And we already know that there's a little spinning shaft there with a tiny little gear. Let's take a look at what happens in the operation of this when it's in a full magnetic motor starter. Well, all sorts of stuff going on here. First, we have from the contactor, this is the connection to my overload relay, and then this is going off to the motor. So full load current, like motor line current, would flow through the top, and we know that that motor current is going to cause heating here in the enclosure for the solder, or that melting alloy. Down here is the control circuit conductors. And the control circuit conductors connect to a normally closed contact, and then they continue on. And so the purpose of the overloads in a magnetic motor starter is not to interrupt the main motor current. Notice how it's very separate. Instead, the only purpose that this serves is to de-energize the electromagnetic coil of the starter itself. So let's go through the operation based on our understanding of where these two items are located in the control circuit. So we got a power and a control circuit. So we got a little bit of spring tension, right? A little bit of spring tension moving to the right, and a little bit of spring tension moving vertically up. Normal motor operation, the alloy in this little capsule does not melt. If we have an overload condition, the alloy will melt inside there, and that will allow for our little gear to spin. And it's going to spin because of the upward spring tension that causes this contact to open, and it's blocked up against that gear, right? So liquid solder allows the wheel to rotate, and then what happens? The contact opens on the bottom, and that de-energizes the electromagnetic coil of the starter. So what will then happen if the coil de-energizes of the starter? Well, the starter will go back to its normal position, which means all the contacts open. So the control contact opens, and then all of the main power contacts open, which means the motor is stopped. So we can reset this, obviously, but you have to physically push it down. You have to wait until the solder or that metal inside solidifies. So you can't reset it immediately. It takes a little bit of time. What about bimetallic strip overload? Same idea. It's a bending strip based on heat. And I'm only going to show a small portion of the entire circuit. So there's a normally closed control contact. There's the heater, and I'm showing one of three. So there's my motor, and there are the power contacts on my contactor, or the motor starter, right? And this is the motor starter coil. So under normal operation, the current flows through this little heating element, but it's not enough current to cause heat to reach such a point where this starts to bend. As soon as the motor becomes overloaded, the current is higher, and because of that, the heat generated is higher also. This causes a bending of the bimetallic strip, and as it bends, it opens this control contact. As soon as it opens the control contact, remember, what's it doing? Its only purpose is to de-energize the coil, right? So it de-energizes the coil, and in doing that, the contacts open, so the motor turns off. So there's all sorts of different arrangements of this equipment. This is an overload relay to a larger magnetic motor starter. And you can see 1, 2, 3 sensing elements, or heaters, and they have a current value here listed on them. Depending on the size of the motor and the service factor of the motor, I will adjust these. So these have a little bit of adjustment to them. You'll notice dial setting ABCD. So each of these heating elements can be used for 1, 2, 3, 4 different categories of motor based on the current. So here's the cam that I would set. And then you'll notice there's also another cam that says M and A. So that's manual reset or automatic reset. And the reset button is here. So if it trips, you can either have it set up so that you have to press the button to reset it, or it just resets on its own after it cools. There's the heating element for that particular manufacturer. And again, all it is a big chunk of metal that will cause a precise amount of heat with the current that flows through it to the motor. This would be the entire assembly because we have 3 of those little heaters and 3 little bimetallic strips. Another type is an electromagnetic coil. And that's where, rather than the heat being generated, what we're doing is we are causing electromagnetic flux with the current. More current means more electromagnetic flux. And so right now, what we have is the normally closed contact up here, and then down here, the sensing portion. And all we're going to do is we're going to treat this like a wee little relay. And as the current value through here increases, it'll cause more magnetic flux or a stronger attractive force to this armature, and it will open that contact. So motor's running, overloaded motor, more magnetic flux generated, draws the contact down. As soon as that happens, it opens the control circuit and that contactor coil de-energizes, which causes the power contact to open. The motor turns off, and obviously it can then go back to its original position. The last method would be with CTs, current transformers, where they're actively sensing the amount of current that's flowing. Not something we get into a substantial amount here, but we would see these on electronic motor starters or VFDs, variable frequency drives. So there's loads of different applications. Not every overload will be a toaster. Some will be electronic, and others will use electromagnetic flux. And there's just the last example. And that brings us to the end of our operation of motor overloads in a magnetic motor starter.